Hello everyone. Happy New Year. This is our newest random lecture. Last time I called these lectures the boring lectures. Then some friend found me and they said, no, these lectures are not boring and I'm not Elon Musk. So why not find a juicier name? So now I'm calling them the random lectures. Hope it's better. Today I'm going to talk about Java concurrency. Another word for it, more general name, is parallelism. However, for Java, concurrency means optimizing one CPU, whereas parallelism means you really have multiple CPUs working together. However, I will use the two words interchangeably here because they both mean doing different things at the same time. So let's start. A brief introduction to Java concurrency before we run to the example. The basic idea is to run multiple chunks of code at the same time, multiple jobs at the same time. So sometimes your CPU is doing the actual computation, sometimes your CPU is reading and writing to and from the memory, and it still has some free capacity to do the computation. If you do multiple jobs at the same time, your CPU can be really efficiently used. So that's why concurrency speeds up your code. We will see that in our example later. Some key terminology here before we start. Java concurrency is also called multi-threading, where a thread is an independently running execution that goes concurrently with the other thread. So a thread is actually an instance of the thread class. So how to tell the thread what to do? Well, in the constructor, you feed into the thread a Runnable object, which is an instance of a class that implements the Runnable interface. Inside the Runnable interface, there is always a method called run, which contains the code that is actually executed. The run method looks like this: public void run, no argument. Then inside the bracket, you write whatever is run. Okay, let's start. So here is our example, which is very simple. The problem is to compute the sum of 300 million integers. That's it. So if we do it the usual way, that's very simple. We accept the input array of 300 million integers, the int bracket a, and we initialize the result to 0, and we add whatever is in the array one by one. We iterate 300 million times, and we return the result. That is our sum. That's it. So for parallel solution, what we do is we want to separate the 300 million integers into 3 arrays, each containing 100 million integers. Okay, why 3? I just want to illustrate the idea. You can do any number you want. Okay. So basically, we separate the 3 arrays, we feed them into 3 different threads, and we compute the sum of each subarray at the same time, concurrently inside those threads. And after that, we tally up the results, we add up the results for the 3 subarrays. That's it. Okay, this is our idea, and let's see how to implement our concurrency. So step 1. Because for our subarrays, we still need to compute their sum, we still need this method arraySum. But this time, we want to write it in a way that our threads can understand. So later we can run those threads concurrently, which means now we need to wrap up the arraySum method into a Runnable class, or a class that implements the Runnable interface, which I have written here. Public class concurrentsum implements Runnable. So in this Runnable class, the core function remains exactly the same. So here we have exactly the same arraySum method as before. Now what we do is to write the very important run method. The run method accepts nothing, outputs nothing. So how does it relate to our arraySum? Well, we need to define 2 new variables. sum and int array, which are fields of this class. Very important. So the int array is an integer array that corresponds to the input of the arraySum method, and the sum is of course corresponding to the output of the arraySum method. So as we hit the run method and object.run, the sum magically equals to arraySum of the int array. Okay. Now this class needs to communicate with the outside world. So how does it accept an external integer array? Where we use the constructor. So in the constructor, we accept an external integer array and int array. The field inside equals to the external whatever integer array. And now after it computes the sum, it needs to again communicate with the outside world. So we write a getSum method that returns the sum after we have computed the array sum using the run method. So that's it for our REPL class of arraySum. Okay, now we need to write the main method. So here is the main method that I have written, which looks intimidating, but is really nothing more than what I have said before about the concurrent solution of adding up 300 million integers. So we have 3 integer arrays, array 1, 2, 3. Each is a random array of 100 million integers. Those are our inputs. We feed them into 3 concurrent sum objects, CS1, 2, 3. We new them by feeding them the array 1, 2, 3 as inputs. Now what we do is we new 3 threads, and each thread is created by the Runnable objects CS1, 2, 3. Okay, and this already looks like an onion. You feed this into this and this into a thread, but you will be very familiar with it once you get practice. Now we have 3 threads. We can hit start. So thread, any thread dot start simply means you run the run method in the Runnable objects. So what I mean is t1.start is equivalent to cs1.run. It runs the run method in the Runnable object that creates the thread. Okay? Now what we do is we start 3 threads, and believe it or not, the 3 threads run concurrently. And we need to wait for all the threads to finish or to die. So we use the method t1, t2, 3, t3.join. So if we don't do this, whatever is after is also run concurrently with the t1, 2, 3. We don't want that because we want to wait for everything to finish before we compute the total sum of those 3 subarrays. So we wait for all threads to die, then we compute total sum equals cs1.getSum plus cs2.getSum plus cs3.getSum. We simply ask those concurrent sum objects to tell us what is their result, their sum. Okay, that's basically it. And now we print out concurrent sum equals to whatever it is. And we time how much time it takes to run the concurrent solution. Okay, that's it. And just for comparison, I also tested the non-concurrent, the sequential solution that we have seen before. So to time whatever process, we simply write start time, end time, and the total time is end time minus start time. Okay, that's it. So if we run the main method, here is our result. The concurrent sum and sequential sum are exactly the same, which is satisfying, and the time for concurrent programming is much shorter. So we have really seen that concurrent programming helps us save time. However, you can ask yourself, is it always true that any concurrent solution is faster than the sequential solution? A hint is I used 300 million integers. What if we have fewer integers? What will happen? In summary, concurrent programming helps us divide and conquer a problem and run those divisions in parallel to save time. What we do is we wrap the key method into a Runnable class. In that Runnable class, which implements the Runnable interface, the fields correspond to the input and outputs of the key method. The constructor accepts external inputs. That's the way it communicates to the outside. The run method, very important, it executes the key method. And we need to write another method to deliver the outputs to the outside. Now in the main method, we need to new a thread Runnable object as input. And we can use t.start to call the method aRunnableObject.run. And we use t.join to wait for the thread to die before we tally up the results. So that's all for today. Hope you have learned a lot of things. Thank you very much. Hope you enjoyed. And please subscribe to my channel to have more random lectures. Bye bye.